Hello everyone, a very good afternoon and welcome to my course Basic Physics. This course is generally made for diploma degree students of first year, first semester. Myself, Gopal Chakraborty, Assistant Professor, Department of Physics, Greater Kolkata College of Engineering and Management, Baraipur. So you can personally meet me at college premises, ground floor physics lab. You can also send me a mail regarding your query or doubt on this topic to my given mail address, that is godphysics6@gmail.com or gopal.chakraborty_gcem@jisgroup.org. So the students, I have a YouTube channel. You can subscribe my YouTube channel for your video class lessons as per the State Council syllabus. I have already uploaded lots of video on the subject basic physics for your study purpose. So you just go through that videos, and if you feel any doubt, any query, please feel free to contact me at the given mail address. The course pages are www.webscte.org and www.webscte.co.in. So the syllabus for the subject basic physics is already uploaded in the State Council website. So students, you can download your first year, first semester syllabus from the university web page as I have given here. So the title of this course is Basic Physics. It is under the category of Basic Science course. It has a credit 3, 2 lecture per week and 2 practical class per week. So this course is generally made for diploma degree students of first year, first semester. So all branches except architecture, photography, multimedia and printing technology students have to study this course for their first year, first semester. So as per our college, the students of electrical department and electronics and communication department students will going to study this basic physics course in their first year, first semester syllabus. So for this, I am your subject teacher. Now the topic that I will going to be discuss are estimations of error. So concept of significant figure, absolute error, relative or proportional error and percentage error, accuracy and precision of instrument. So some example with slide calipers, screw gauge and some numerical problem also. These topics are also under unit 1, that is unit dimension and measurement. So prerequisite for these topics are basic mathematics knowledge to solve the problems, knowledge of basic concepts, science such as physics. The corresponding course objectives are learn about estimations of error in measurement. So after completion of this topic, students will able to know the idea of estimations of error during the time of measurement. They will also able to calculate different types of error in physical measurements. So these are the corresponding course outcome for this today's topic. So error. before starting to discuss how many types of error, how you will find that, what are the significant numbers, how you rounding of that significance number, I would like to introduce that what do you mean by that error. Say when you are taking some measurement, you need some instrument to measure that quantity, and when at the time of the making of that instrument, some uncertainty is introduced in it. Okay, so if you measure the value, what you will see? You will see that you will get a different value with respect to the actual value of that measured quantity. So that means this is the error. So error means that gives the difference between true value and measured value. So from where that error is come? Error may be comes, or it may be introduced in so many ways. In some case you may know the reason, in some case you may not know the reason. Okay, so from where it comes, if you know the reason, so that your error it occurs in a single direction, that means in a positive way or a negative way, or you can remove it as you know the reason of that error. So that is called systematic error. Or it will be if it is a random error, you cannot rectify that error because you don't know what is the actual reason behind that error. So so many types of error is there. Before discussing that, I will discuss you about the rounding off or the significant number, significant figure. So significant figures or number, that is, the term significant figures actually refers to a particular digit in a number. These are sometimes called the significant digit. In this document, we will use the term significant figure to discuss the broader topic. That way we may still say digit to draw your attention to a particular digit under discussion. So after you have become familiar with the topic, you may use either term. So how can you introduce the significant figure? So only those figure or digit of a numerical quantity which are the result of actual measurement are said to be significant. For an example, if you measure the thickness of a coin, you can write it as 1.6 millimeter or 0.16 centimeter or 0.0016 meter. So how many significant figures are there in this measurement? Clearly, only the digit 1 and 6 are the actual measured values. Therefore, we have only two significant figures. Zeros used as placeholders are not the significant one. So this would include all of the zeros in 0.0016 meter. So we can use scientific notation to avoid misunderstanding. We would report the measurement as 1.6 millimeter or 1.6 into 101 centimeter or 1.6 into 103 meter. So with the use of scientific notation, every digit that appears is significant. Here are some examples. The examples are 2.736. So here 4 number is there, so 4 significant figures are there. 2.00 has 3 significant figures. 4 into 103 has only one significant figures, but 4.0 into 103 has two significant figures. So standard notation would not let us distinguish between the last two examples. They would both appear as 4000. Now the next one, that is also most important, that is rounding off. When computing results on a calculator, we often end up with many digits displayed because computation itself cannot increase our measurement accuracy. We must decide how many of these figures are significant and round the result back to an appropriate number of figures. So here the rules for rounding off are: once you have decided how many figures you will keep, look at the first digit you will reject. When the first rejected digit is less than 5, you will round down. So simply delete the rejected digit. When the first rejected digit is greater than 5, so then this means you will be rounded up. That means you will still delete the rejected digit, but now you add 1 to the last digit you keep. If the first digit rejected is equals to 5, rounds up or down so that the last digit retained is even. If we always round 5 up, we will distort the results for every large data sets. So here some examples is there for your reference. That is, say example is you consider the number 273.92. So rounded to the up to 4 digit is 273.9. So as the last digit is 2, it is less than 5, so you can simply delete it. So your result is 273.9. Another number, it is 1.97, rounded up to 2 digits, second digit, that is 2.0. So here you can see the up to second digit is 9, which is greater than 5. So that means you just add 1 with the first one, say 1 plus 1 make it 2, and delete the rest part. Third one, that is 2.55, rounded to second digit, so it is 2.6, because you see the third number is again 5, so you just round it up. That means you just add 1 with the second number, so it is 2.6. 4.45 rounded up to second digit, that is 4.4. If you do not round after a computation, you imply greater accuracy than your measured. Now I will going to discuss about the error. So what is error? Error are a measure of lack of certainty in a given value. So as I have already told you that it gives you the difference between true value with the measured value. So I will explain with some examples so it will be very clear to you. So here the first example, that is the width of piece of A4 paper is 210.0 plus minus 0.5 millimeter. So I measured it with a regular 1 divided in unit of 1 millimeter and taking care with measurement. So I estimate that I can determine length to about a half a division, including the alignments at both ends. Hence, the error reflects the limited resolution of the measuring device. Second example, an electrolink balance is used to measure the weight of drops falling from an outlet. So the balance measured accurately to 0.1 milligram, but different drops have weights varying but much more than this. Most of the drops weighed between 132 and 139 milligram. In this case, we could write that the mass of the drop is 136 plus minus 4. So here the error reflects the variation in the population or fluctuation in the value being measured. Next one, error has a technical meaning, which is not the same as commonly used. If I say that the width of the seed of A4 is 210 centimeter, that is a mistake or blunder, nor an error in the scientific sense. So mistakes such as reading the wrong value, pressing the wrong button or on a calculator or using the wrong formula will give an answer that is wrong. So error estimates cannot account for the blunders. So to understand the error in details, you need to know this definition very clearly. These terms are very important to measure the error. So first one, observed or calculated value. So a value either observed or calculated from observations. Therefore, the value obtained using a ruler to measure length, or the electronic balance to measure mass, or a calculation of the density based upon this. Second one, true value. So the true value is a philosophically obscure term. So according to one view of the world, there exists a true value for any measurable quantity, and any attempt to measure the true value will give an observed value that includes inherent and even unsuspected errors. Most practically, an average of many repeated independent measurement is used to replace true value in the following definition. Next one, accuracy. Measure of how close the observed value is to true value. A numerical value of accuracy is given by accuracy equals to 1 minus within bracket observed value minus true value into 100%. Precision. A measure of the details of the value. This is often taken as the number of meaningful significant figures in that value. Now, how many types of error? That is systemic error and random error. What is systemic error? As I have already discussed that if the error occurs in one direction, that means either positive or negative, we can eliminate such error once we know the rules which governs them. So that means we know the reason of this error, so that we can reduce the error by changing that reason. So systematic error, example of systematic errors are, so one is instrumental error. So there may be some manufacturing defect. So if you choose a good instrument, a better instrument will give you a better result. So by this way, if you choose a good instrument, you can reduce that error. Secondly, when you are taking the reading manually, so that means it will vary by person to person. So this personal error, that means due to lot of inexperience, one can increase the error in taking the measurement or taking the reading. So experienced one can reduce this error. So these are the examples of the systemic error. And random error, what is random error? The error which occurs irregularly and is random in magnitude and direction. These are called the random error. So you cannot reduce that random error because you don't know what is the actual cause of this random error. So you can write that the systematic error is 1 that is reproduced on every simple repeat of the measurement. So the error may be due to the calibration error, a geo error, a technical error due to the experimenter, or due to some other cause. And the random error changes on every repeat of the measurement. So random errors are due to some fluctuations or instability in the observed phenomena, the apparatus, the measuring instrument, or the experimenter. So you don't know what is the actual cause of it. Now came to the part that is independent and dependent error. So diameter of a solid sphere object is 18.0 plus minus 0.2 millimeter. So the volume calculated from this usual formula is 3.1 plus minus 0.1 centimeter cube. So these errors are dependent. Each depends on the other. If I overestimate the diameter, I shall calculate a large value of the volume. So if I measure a small volume, I would calculate a small diameter. Any measurements made with the same piece of equipment are different. So here, so that means what I want to say that volume of that sphere equals to 4/3 pi r cube, as we know the formula. So as if you put a lot of error in the measurement of our radius, so simultaneously the error in volume will be also large. So it is a dependent error. But when you are taking the when you are measuring the radius, so if you done some mistake, so it will be an independent error because radius is not dependent on the volume. So what is absolute error? These are very important to calculation in the calculation of error. So if the true value is ever, and when you are taking the measurement, say for the first observation give and second, third will give you the value A1, A2, A3 and so on. So the absolute error is the difference between the true value and the measured value. So for first absolute error will be A bar minus A1, second will be A bar minus A2 and so on. So after finding out all the absolute error, you can easily find out what is the mean absolute error by taking the average of all the absolute error. Now the next one, that is relative error. What is relative error? Relative error is nothing but what is the error with respect to the actual value. So that means it is the ratio of mean absolute error with the true value. That is your relative error. And last one, that is percentage error. So if the relative error can be expressed in terms of percentage, so it will give you the percentage error. So these three are very important, that is true value, absolute error, relative error and percentage error. Now I will show you how you will calculate the error when you are taking sum of these two quantity, or when you are subtracting, when you are multiplying, when you are dividing, how you will calculate the error. So here first of all, say you consider that you have to take the sum of A and B, okay, and your result is Z equals to A plus B. So now you measure the value of A and the error is plus minus del A. So the new A dash can be written as A equals to A plus minus del A, and the B dash can be written as B plus minus del B, where plus minus del B is the error in measurement of B. So before taking the measurement, what the actual value of A plus B, that is equals to Z, okay. And now what is Z dash? That is the total sum of the value of A dash and B dash, that means after taking the measurement with error. So Z dash equals to A dash plus B dash, okay.
So as you know, a dash value is equals to a plus minus del a, and b dash value is b plus minus del b. So similarly, you can write what is the total error in measurement of z, that is plus minus del z. So z plus minus del z, that is equals to a plus minus del a plus b plus minus del b. Okay, so now as you know, z equals to a plus b. So from the both side a plus b, that will cancel out. So ultimately what you will get del z, that is equals to del a plus del b. So that means your total error in measurement of the sum, that will be equals to the sum of individual error in the measurement. Similarly, you can also find out the error when you are going to find out the difference of two quantity. So here only the difference is, as in the first case you have considered z equals to a plus b, here you have to consider z equals to a minus b, and if you substitute the all values, so z plus minus del z, that will give you a plus minus del a plus b plus minus of b plus minus del b. So all the quantities are cancelled out, and again ultimately you will get del z, that is equals to del a plus del b. So hence the rules are same, that maximum error in the difference of two quantities equals the sum of the absolute error in the individual quantities. Now error in the product of two quantities, again you just put z equals to a into b. Z is the result of product of a and b. So you substitute the value of a, that is a plus del a with the error, and b, that is b plus del b, considering the error in b. So your result will be z dash equals to a dash into b dash. You substitute that value. Z dash means z plus minus del z with the total error, and a plus minus del a into b plus minus del b. So if you calculate, you will get ab plus minus a into del b plus minus b into del a plus minus del a into del b. Now dividing both sides by z. So as you know, z equals to ab. So in left hand side what you will get 1 plus minus del z by z. In right hand side, that is 1 plus minus del b by b plus minus del a by a plus minus del a by a into del b by b. So last quantity, that's too small, so you can neglect that. So you will get ultimately del z by z, that is equals to del a by a plus del b by b. So these are the formula, that rules that you can apply. That means the maximum fractional error in the product of two quantities is equals to the sum of the fractional error in the individual quantities. Now error in power of quantities, that is z equals to a to the power n. So by the similar way as I have discussed in the last derivation, here also you will get the error is del z by z, that is equals to n into del a by a. So the fractional error in the nth power of the quantity is n times the fractional error in the quantity. So in general, if you write z value is equals to a to the power p, b to the power q, c to the power r, so the fractional error can be written as del z by z equals to p del a by a plus q del b by b plus r del c by c. Now I will show you some example numericals, so that the measurement of error, that will be very clear to you. The first problem, that is the initial and final temperature of a water bath are 18 plus minus 0.5 degrees C and 40 plus minus 0.3 degrees C. What is the rise in temperature of the bath? So rise is temperature, that is final temperature minus initial temperature. So if you substitute that value, you will get 22 plus minus 0.8 degrees C. Second example, the resistance R equals to V by I, where V equals to 100 plus minus 5 volt and I, that is equals to 10 plus minus 0.2 ampere. So find the percentage error in R. So the percentage error in V is 5% as is given here, and in I is 2%. So total percentage error in R is given by del R by R into 100, that is equals to del V by V into 100 plus del I by I into 100. So that's equals to 5 plus 2%, that is equals to 7%. Next one, if the error involves in the measurement of a side of mass of a cube are 3% and 4% respectively, what is the maximum possible error in the density of the material? As you know, density equals to mass by volume, so volume is equals to L cube, so M by L cube. Now the percentage error in density is given by del rho by rho into 100, that is equals to del M by M into 100 plus 3 into del L by L into 100. So that is equals to 4% plus 3 into 3%, that means total 4% plus 9% is equals to 13%. Next one, the error in the measurement of a radius of a sphere is 2%. What would be the error in the volume of the sphere? So the given is del R by R into 100%, that is equals to 2%. So as you know, volume of a sphere V equals to 4/3 by R cube. So del V by V into 100, that is equals to 3 into del R by R into 100. So 3 into 2, that means the result is 6%. Next one, the specific resistance sigma of a thin wire of radius r and resistance capital R, and the length L is given by sigma equals to pi small r square capital R by L. So if r equals to 0.26 plus minus 0.02 centimeter, capital R equals to 32 plus minus 1 ohm, and capital L equals to 78 plus minus 0.01 centimeter. So what is the percentage error in sigma? So as we know, sigma equals to pi r square into r by L. So the error, percentage error in sigma, that is del sigma by sigma into 100, that is equals to 2 del small r by r plus capital del R by R plus del L by L into 100%. So all the quantities are given here. So 2 into 0.02 by 0.26 plus 1 by 32 plus 0.01 by 78 whole into 100%. So ultimately will give you 18%. So this is the required percentage of error. So these are the reference book that you may consider. So the evaluation process is same. You have to appear for a 70 marks end semester exam and 20 marks mid semester exam and 10 marks for attendance, assignment or interaction. So with this today's class, I have completed the first unit, that is unit dimension and error. So hope all of you have understand and enjoyed my class. Thank you.